Dear students, welcome to EPG Pathshala. In this module, we will discuss about what is probability. In real life, we usually say the probability means chance, that means occurrence of any event, and what are the chances that that particular event occurs. So in this module, we will discuss what is probability in terms of mathematical term. For that, we require knowledge of some terminology. So we introduce in this module some terminology here as well as uh, approaches that are used to understand the concept of probability. So we also introduce some introduction about different types of events, as well as we also introduce some concept of permutation and combination. To understand the probability approach, one need also understand the concept of probability approach. So we will discuss all these approach in very depth and easy manner so that one can easily understand these concepts and one can apply these concepts in real life. Let's get started. The objective of this module is to introduce key concepts that help to understand probability problem in simple words and different approaches to find numerical measure of probability for different probability problem. Examples and some integers are used for better explanation of this topic in an easy manner. Probability measures the uncertainty of an event in an experiment. Theory of probability is an important branch of mathematics and statistics that provides numerical measure of the probability. Probability is also used in our daily life. Likely, possible, high chances of use of like words in day-to-day life to express uncertainty of happening an event. For example, possibly it will rain today and there is a high chance to get my dream job in next 2 months. According to Yarlin Chow, probability is a science of decision making with calculated risk in the face of uncertainty. Probability phenomenon is mostly observed in business, economics, social science, daily life, and actuaries. Probability has many applications in economics, business, and actuaries because there are terminologies such as risk, taxes, profit, loss, etc. These terminologies express uncertainty of an event under an experiment. Suppose an investor invests money in money market, there are chances that either investor will get more money as profit of investment or will make or will face loss in the investment. This shows uncertainty. Probability terminology can be used here. Now we will discuss the basic terminology that is essential to understand the concept of probability. There is a need to be aware about some basic concept of probability before going to numerical measure of probability. In this section, focus will be on key concept to understand a probability problem in words and convert into numerical form to solve it by using different approaches of probability according to the feature of the problems. Key concepts are given as random experiment. Before conducting an experiment, there is no possibility to get outcome of any problem. Experiment is a process to observe an uncertainty in the problem. Random experiment is an experiment in which outcome of a trial or event under some identical circumstances are not unique, but it will be among all the possible outcomes. Some examples of random experiments are tossing a coin, observe risk of an investor, selecting a card from a deck of cards, selecting a ball from a group of ball, arrangement of persons in a queue, observe the number of Xiaomi Android phone sold by Amazon in 2017, selecting a student from a classroom, observe the number of wickets in a cricket team, observe product of a process in manufacturing company, observe a bulb is either fused or not, observe a person who speak either truth or lie. Observe the number of car accident in particular place. Observe the number of births in India in year 2017. And at the last, we consider example of share market prices. Outcomes. After conducting what is random experiment, now to observe the uncertainty of a problem. There will be some results or outcome of that experiment. Outcome gives us an idea about all possible results of that experiment. So basically output is a result of a random experiment. Here we list some of the outcomes of random experiment, and these are outcome of a tossing coin. It can be either head or tail. Second is outcome of rolling a dice. As we know that dice has 6 faces, so outcome can be 1, 2, 3, 4, 5, 6, any one of the 6 faces. Outcome of selecting a ball from a group of different colors of balls like blue, red, white, blue, red, white. So outcome will be either blue, either red or white. Outcome of risk of an investor, that is high risk, neutral risk, low risk or no risk. So these are the possibilities that one can see if one investor invest his money in the market. Outcome of selecting a card from a deck of card. So we know that there are 52 cards, and so outcome will be 1, 2, 3 up to 10, J, Q, Jack, Queen, A, club, space, etc. So outcome of working condition of a bulb, either the bulb is fused or not fused. Outcome of a person speaking tendency, that it can be true or lie. Outcome of observing car accident in a state, so we can say that either one accident occur, either two, and so on. So there is no upper limit on the occurrence of an accident in a particular state. Outcome of product quality in a manufacturing company, the product can be defective or non-defective. Now we have to understand what is sample space. After identifying the result of the experiment, there is a need to arrange all the possible outcomes. In basic mathematics, the definition of set was described. Set is a group of well-defined objects that related to each other under same condition. Here, result of an experiment is well defined, different result under same consideration. So, set is used as sample space to arrange all the possible outcomes. Sample space is set of all possible outcomes of an experiment. So list of some examples of sample spaces are sample space for tossing a coin. So we know that coin has two faces, either head or tail. So the outcomes, so the all possible outcomes are head comma tail. So sample space for rolling a dice, as we already discussed that dice has 6 faces. So the all possible outcomes, if we combine it in a set, it is called sample space. So 1, 2, 3, 4, 5, 6 is the set. Sample space for selecting a card from a deck of card is given here, and sample space for selecting a ball from a group of ball of different colors, blue, green and red, are blue ball, red ball, green ball, because we can select one ball at a time. So sample space is the collection of all the different colors of balls. Sample space of observed risk of an investor, so it can be high, low, neutral or no risk. Sample space of product that produces by manufacturing company, as we already discussed that two outcomes are there. So if we combine them, these two outcomes, the samples will be defective or non-defective. Sample space of observe a bulb, that is fuse and non-fuse. Sample space of observing person talk, a person can tell a truth or a lie. So we have sample space as truth or lie. Sample space for observing car accident in a state, that is 1, 2, 3 and so on. Sample space for observing the number of wickets in a cricket match, it lies between 1 to 22, because we have 11 persons in a team, so total wickets are 22. Events if one is interested in different results among all possible results of a random experiment, these particular results can be obtained in terms of events. Events is a particular performance of a random experiment. List of some examples of events are: suppose a random experiment is tossing a coin 2 times. The sample space is HH, HT, TH and TT. So, and the possible events are getting head both time, getting tail both time, getting one head and a tail of a coin. Suppose rolling a dice 2 times is a random experiment, then the sample space is 1, 1, 1, 2 and 1, 6, because we are taking 2 dice and we have to consider all the possible combinations. So here sample space consists of all the possible combination, and the possible events are getting same number both time, getting odd number at first place and even number at second place, getting odd number at first time, getting sum of both is even, getting sum of both time is odd. Many more events may occur. And a third case, selecting a card from a deck of cards is a random experiment, and the possible events are getting a spade, getting a club, getting a heart, getting a diamond, getting a face card, getting a king and so on. So many more events may occur respect to sample space of random experiment. So what is simple event? There are many types of events according to the happening of event and outcomes. Types of events are defined as simple event. Suppose a particular event happens among all possible events, result of particular event is at most one, then event is called simple event. An event that shows exactly one outcome of an experiment is a simple event. For example, suppose a quality analyst analyzes two processes product in a random experiment and classify the process product as defective product and non-defective product. So sample space is of this form: NN, ND, DN and DD, where D is the defective product and N represents the non-defective product. Let N is an event, so event E, either product is defective and E should be is equal to NN, and as E has only one outcome, so E is a simple event. And another example is tossing a coin 2 times in a random experiment. Sample space consists of head tail, tail, where H represents head and T represents tail. Let E be any event getting head both time. So E should be is equal to, there is only one possibility that while tossing a coin 2 times, head only can occur. So E has only one outcome, so E is an simple event. Suppose a particular event happens among all possible events, result of particular event is at least one outcome, that event is called a compound event. An event shows more than one outcome of a random experiment is a compound event. For example, suppose a quality analyst analyzes two process product quality in a random experiment and classify the process product as defective product and non-defective product. So sample space consists of these outcomes, and where D is for defective product and N is for non-defective product, and E is an event, at least one product is defective. So E consists of more than one event, so that's why E is called compound event. So this is a difference between simple event and compound event. In simple event we have only one outcome, and in compound event we have more than one outcomes. Another example is tossing a coin 2 times is a random experiment and sample space is of this form, and let E be an event getting head at least one time. Similarly, we get head at first place, at second place, and both time we will get head. So E has more than one outcome, so E is a compound event. Now we will discuss another event that is called exhaustive event. All possible results of an experiment is termed as an exhaustive event. Exhaustive event is the total outcome of a random experiment. List of some examples are: tossing of one coin is a random experiment. Exhaustive cases are 2. Throwing a dice, exhaustive cases are 6. Throwing 2 dice, exhaustive cases are 6 power 2. Tossing two coins, exhaustive events are 2 power 2. Selecting a card, exhaustive cases are 52. Now we will consider the definition of dependent event. Two particular events E and capital F occurred in a trial. Result of one events are affecting the results of second event. Event may be either capital E or F. These events will be dependent event. Event is said to be dependent event if happening of one event in one trial is affected by happening of similar event in next trial. For example, drawing a card from a pack of cards followed by one after another draw is a random experiment. Let us consider capital E is an event of drawing black card. If first drawn card is not replaced in the deck of card while second card is drawn, then the second time drawn card will be dependent on the first drawn card. After this, total number of cards are decreasing followed by one after another draw. So E is a dependent event. Let us consider a bag with 5 marbles. 4 are red and 1 is blue. If a marble is selected at random from the bag and not replaced again into the bag, the chance of occurrence of blue ball will keep increasing with each consecutive draw. Now we will discuss the definition of favorable event. Outcome of a particular event are favorable to that event. These outcome of events are considered as favorable event. Favorable event is a number of outcomes favored to an event. For example, tossing two coins is a random experiment and getting head on both coins is an event. So exhaustive event is 2 power 2, that is equal to 4, and favorable event is 1, that is head and head. Throwing two dice in a random experiment and getting same number on both sides is an event. So favorable event is 6, that, and these are the favorable event, that is 1, 1, 2, 2, 3, 3, 4, 4, and so on 6, 6. Now the definition of mutually exclusive event. Events cannot occur simultaneously in same trial are mutually exclusive events. Suppose we have two events A and B. If A and B are mutually exclusive event, then one can easily see from the Venn diagram that these two events do not overlap on one another. So these are called mutually exclusive events. Some of the examples of mutually exclusive events are: head and tail are two outcomes of random experiment of a coin. Suppose capital A and B are two events of getting head and getting tail respectively. Both events cannot occur in a single trial. So A and B are mutually exclusive event. Second is, if we have 6 outcome of random experiment while throwing a dice, all these outcomes cannot occur in a single trial. So they are all mutually exclusive events. A switch cannot be on off at the same time. Switching a switch button is a random experiment that has two possible outcomes, on and off. That switch is on while the second one shows switch is off. Both events cannot occur at same time. So A and B are mutually exclusive events. Now coming to the definition of independent event. Two particular event E and capital F are occurred in a trial. Result of one event is not affecting the result of second event. Event may be either E or F, so these events will be independent event. Event is said to be independent event if happening of one event is one trial is not affecting by happening the similar event in the next trial. Examples of independent events: throwing a dice is a random experiment. If one gets 6 in first throw as well in second throw, one can see that both throw of a dice are not affecting the outcome of each other, so these are independent events. Tossing a coin is a random experiment. If one gets head on first toss as well as second toss, one can see that both tosses of a coin are not affecting the outcome of each other. Drawing a card from a pack of cards with replacement is independent event. Every time total number of cards remain same. Now the definition of equally likely events. All possible events of a random experiment have same numerical value or probability of occurring event. These events are known as equally likely event with equal probability of occurrence. Equally likely event shows equal probability for all events. There is no preference for one event, all have same preference. There are few examples of equally likely events. These are: tossing a coin is a random experiment. Possible outcomes are head and tail. Possible events are getting head and getting tail. One has total possible outcomes at 2. Probability of getting head is 1 by 2 and probability of getting tail is half. Both have equal probability and equal preference, so events are equally likely events. Throwing a dice is a random experiment with 6 possible outcomes and events. All possible events have equal probability, that is 1 by 6. So all events have equal preference to happening, and it is called known as equally likely event. If an event under random experiment cannot occur, that event is known as impossible event. Numerical measure of an event is 0, then the event is impossible event. For an event capital E, probability of capital E is equal to 0. For example, if a tossing a dice is a random experiment, E is the event of outcome greater than 6. We know that dice have 6 faces only, so there is no chance of happening this event. Hence, event E is an impossible event. Certain events. If there is an absolute surety on the chance of occurrence of an event is known as certain events. Suppose if it is Thursday, the probability that tomorrow is Friday, then there is a certainty that tomorrow will be Friday. So the outcome is 1. That is means the probability of E should be is equal to 1. Then this type of event is called certain event. So numerical measure of an event is 1, then event is a certain event. For example, hitting a dart is a random experiment and throwing a dart at center is an event on the dashboard. Imagine that this is only one thing in the universe and dart hit at the center. There is only one chance to throw, then this event is a sure event. Now we will discuss now complementary event. Non-happening of an event is known as complementary event and it is denoted by AC. That means AC represents A complementary. Sum of happening and non-happening event will be 1. So it means the probability of A and plus probability of A complement should be is equal to 1. So for example, tossing a coin is a random experiment and we are interested in getting head. If head appears, then it is a happening event. Getting tail is not happening event and complementary event. Rolling a dice is a random experiment and getting 6 on dice is an event. Getting value other than 6 or not getting 6 is non-happening event and complementary event. Now we will discuss probability approach. After understanding the statement of the problem, next move is to calculate the numerical value of uncertainty. To calculate the numerical value of the probability, several types of approach and method available in the theory of probability. Some of them are discussed here. Most of the time, 3 types of approaches are used to solve probability problem in numerical form. In this section, these 3 approaches are defined. Basically, 3 approaches of probability are also used as a definition of the probability. Now the mathematical approach. Now we will discuss the mathematical approach. This definition of probability gives by James Bernoulli, who was the first person of obtaining numerical measure of uncertainty. This definition of probability is also known as classical or prior probability. If capital F denotes the favorable outcome of an event, E of a random experiment, and T denotes the total possible outcomes, the probability of happening of an event E is given by the formula. In the numerator, we consider number of favorable outcomes divided by total number of possible outcomes. So the probability of E is equal to F divided by T. Note, all possible outcomes in mathematical approach must be exhaustive, mutually exclusive and equally likely. We already discussed the terms in the previous slides, so one can refer the meaning of these terms. So now we will discuss an example of mathematical approach. Suppose a random experiment of randomly selecting a card from a deck of card of 52 has equally likely outcomes. Let event A is equal to king. Probability of an event A is equal to 4 by 52, and B is equal to these outcomes that either can be jack, queen, ace. So probability of event P is equal to 12 by 52. Because we have 4 jack, we have 4 king, queen, and we have 4 ace in a pack of card. So probability of event B should be equal to 12 by 52, and favorable outcomes are 4, 12 and both events. Now, after understanding the concept of probability through mathematical approach, now we will discuss this concept through statistical approach. Probability of happening an event under a random experiment performed repeatedly under regular and identical circumstances is a ratio of number of times event occur to the number of trials. These limits must be unique and finite. Probability of happening event E given by the formula number of event outcome divided by number of trials, and it is equal to n small n upon capital N. This approach of probability is also known as empirical approach of probability due to its repetitive behavior. Now, we will now discuss about subjective approach. Subjective approach is completely biased. Numerical measure of this approach cannot be possible because it is based on biasness, based on person's knowledge, belief, experience and intuition. Suppose one old person assume the chances of cold in winter will be normal and not too cold. One businessman observed the chance of no profit in the business this year. Above example of subjective approach will vary from person to person. This approach is not quite enough to measure probability numerically. Now there are few axioms of non-activity. So one must understand these axioms. So it is helpful to understand the concept of probability in easy manner as well as in depth. Numerical measure of uncertainty to respective event is called probability. For accurate and best result of an event as much as possible, probability must follow some axioms. So axioms are given as, first axiom is axioms of non-activity. Probability of an event must be non-active. Suppose capital E is an event of random experiment. Probability of E should be greater than or equal to 0. Probability lies between 0 and 1. So it means the chance of occurrence of any event lies between 0 and 1. So and it should be non-negative. And second axiom is axiom of certainty. Probability sum of all possible outcomes of a random experiment must be 1. Suppose capital E is an event of a random experiment. Probability of sum of all possible events should be equal to 1. If probability of getting head at first time of tossing a coin is 0.5 and probability of getting tail on first time of tossing a coin is 0.5, total of getting head or tail should be equal to 1. Now axiom of additivity. Probability of union of all events is equal to the sum of probability of all distinct events. It means if you are taking the union of all events, if they are mutually exclusive, then it should be equal to summation of probability of events, where i's are mutually exclusive events for all value of I vary from 1 to n. Now we will discuss the definition of permutation. If a probability problem is related to some specific type arrangement, like arrangement of letters of a word, arrangement of person in a cube, permutation are used to solve these types of arrangement. Mathematical form of permutation. In this we discuss that how one can find the permutation for a given problem, and the formula for permutation is given as n factorial divided by n minus m factorial, where n minus m factorial is equal to n minus n into n minus 1 and so on up to 1. For example, possible permutation of selecting 2 vowels from the 5 vowels is solved by the formula. that is 5 factorial divided by 5 minus 2 factorial is equal to 5 factorial divided by 3 factorial, which is coming out to be 20 after solving the mathematically. As we have 5 overs, so the possible permutation is 20. Now come to the definition of combination. If the probability problem is related to selection of some units from a huge amount of same units, like selecting a ball from a bag, selecting a card from a deck of cards, combination are used to solve these types of selection problem. And the mathematical form of combination is given here as selection of item from group of item defined by combination. When selecting m item from the n items, then the possible combination is given by n factorial divided by m factorial into n minus m factorial. Now here we discuss an example here. Suppose we have a coin and we toss it 2 times, and we are interested to find the probability of getting head or getting head on first time. So coin has 2 possible outcomes, one is head and second is tail. After tossing the coin 2 times, there are 4 possible outcomes. That is, either it can be, outcomes are head head, head tail, tail head, tail tail. Favorable outcomes for events are, if we are interested to find out at least one head, then the outcomes are head head, head tail at the first time, and the total outcomes are 4. So probability of getting head on the first place or on the first coin is coming out to be 0.5. At the end of this module, I am going to summarize this module as we in this module we discuss the definition of probability, as well as we also discuss what is random experiment, what are the sets, what are samples outcome. We also discuss the various types of events like mutually exclusive events, other types of events like possible events, certain events. After that, we also discuss different type of approaches like probability approach of probability, mathematical approach of probability, statistical approach of probability. We also discuss some axioms like non-activity, summation, union of probabilities is equal to summation of probabilities of AI. So hence we try to cover all the things in a very easy manner so one can understand it. So at the end we also discuss permutation and combinations. So hope you enjoy this module. Thank you.